This is part 2 of my thyroid series. Part 1 was all about normal thyroid function, how it works and how it's regulated by the brain. Now we're going to talk about when things are not normal. The two most common conditions affecting the thyroid are Hashimoto's and Graves' disease. Hashimoto's is hypothyroidism, meaning low functioning. Graves' is hyper, and it's overfunctioning. Your thyroid gland sits right here at the base of your neck. You feel your collarbones, and then go to the middle where it creates this notch. Your thyroid gland sits right here, and it's shaped like an H or a butterfly. And in fact, my thyroid is normal size, so you can't really see mine because mine's normal size. And for comparison, this is what an enlarged one looks like. So you can see at the base of her neck, there's a fullness to it, and you can see two distinct lobes, and that's the thyroid gland. It's enlarged in this person. Thyroid hormones are responsible for your metabolic activity. The term metabolism is a term used to describe any chemical processes in the body that produce energy. Thyroid hormones work on virtually every part of your body because every organ and every cell require energy to function. In infants, it has a huge role in brain development. Let's dive deeper and see how all of this works. The thyroid needs iodine to function. So these numbers represent the amount of iodine atoms are attached to tyrosine. That's an amino acid. So this has 4 iodine atoms, this has 3 iodine atoms. And so the way the body attaches these iodine atoms to the tyrosine is through an oxidation reaction. That doesn't really matter, but the point is the reaction or the enzyme that causes this reaction is thyroid peroxidase, otherwise known as TPO. And that might look familiar if you have Hashimoto's and you've tested for this autoantibody. So this enzyme oxidizes iodine, and that's how it attaches to tyrosine, and that's how we make T1, T2. And so get this, all you have to do to make a T4 is put 2 T2s together. All you have to do to make a T3 is to put 1 and 2 together. T2 plus T2 equals T4, T1 plus T2 equals T3. It's really that simple. So now that you have the 2 hormones you need, this is stored in a protein called thyroglobulin. And there are a bunch of thyroglobulins inside the thyroid, so that when TSH comes from the pituitary, it binds to a receptor and it sets off a reaction to eventually release T3 and T4 into the blood. And then it circulates throughout the body. As you recall from the last video, T4 doesn't really have any biological activity. T3 is the biologically active. So the body's T3 is made both in the thyroid and in the body by removing 1 iodine and turning it back into a T3. This T3 that's released by the thyroid is only 20% of your body's total T3. The rest of it comes from removing an iodine from your T4 and turning it into T3. So how does all this play into the pathology of Hashimoto's and Graves' disease? Hashimoto's, there's an autoantibody to this enzyme. This is called anti-TPO antibody. So for whatever reason, your body felt like this was a foreign invader, and so the immune system responded by making antibodies to it. And so this interferes with this process. Now remember, this enzyme is responsible for oxidizing iodine so that it can attach to tyrosine or T to make your thyroid hormones. So if there's an autoantibody preventing this from happening, then you will never get to these steps where you can make thyroid hormone. And so that's why this is considered hypothyroidism, because you're not making enough thyroid hormone. Graves' disease also has autoantibodies, but to different parts of this process. And what's interesting about Graves' disease is that it doesn't inhibit these processes. Instead, it speeds up the processes. So the first autoantibody we'll talk about in Graves' disease is an autoantibody against this receptor. So instead of this receptor being stimulated by thyroid stimulating hormone from the pituitary, instead an autoantibody attaches to this and then just stimulates the living crap out of it. And so this whole process ramps up, and the production of all of your thyroid hormones goes unchecked. You know how when your computer's messing up and so you get mad and start pushing the button over and over again and all it does is break it even more? That's kind of what's happening here. The autoantibodies are stimulating this receptor and just releasing this process way too fast. And as a result, it speeds up your metabolism, and that accounts for all of the symptoms you have in Graves' disease. There's another autoantibody that can occur in Graves' disease, and that's against thyroglobulin. In Graves' disease, what it does is it stimulates this protein to rapidly dump thyroid hormone. It just keeps telling it, okay, keep releasing, keep releasing, keep releasing, because it's stimulating this process. So you get a massive release of thyroid hormone. Coming up next, a very controversial topic: levothyroxine versus Armour thyroid. What are the differences? This is a hotly debated topic. Stay tuned.